Right now, the cold spot is still growing colder, and NASA has no way to stop it. It is a region of sky nearly 1 billion light-years wide. Inside it, the oldest light in the universe is dimmer than it should be, fainter, colder, and it has been getting worse for over a decade. The smartest cosmologists at NASA, at Harvard, at Caltech have pointed every instrument they own at this patch of sky, and none of them can explain why it refuses to warm back up. Some of them think it isn't just cold. Some of them think it's a scar. And what's underneath that scar is the part they won't say on camera. Here's what you're looking at. In 1965, scientists discovered the afterglow of the Big Bang, a faint microwave hum coming from every direction in space, the oldest light that exists, stretched across 13.8 billion years. It's called the cosmic microwave background. It should be almost perfectly even. Almost. In 2004, a satellite called WMAP scanned that glow and found one spot that didn't fit. A patch in the southern sky in the constellation Eridanus, colder than everything around it, not by a little, by an amount statistics say shouldn't happen even once in the entire observable universe. At first, they called it noise, a glitch in the instrument. Then the European Planck satellite checked again in 2013 with sharper eyes, cleaner data. The cold spot was still there. Still cold, still impossibly large, spanning roughly 5 degrees of sky, big enough that if you held up your fist at arm's length, it would swallow it 10 times over. Astronomers ran the numbers. A random cold patch this size, this deep, should occur by chance in less than 1 in 50 scans of the universe. It kept surviving every recheck. And the coldest part sits almost dead center of the whole southern sky map, like something was pressed into the fabric of the early universe on purpose. So they went looking for a boring explanation. The leading one was a supervoid, a stretch of nearly empty space, sitting between us and that ancient light, pulling energy out of the photons as they pass through and leaving them cold by the time they reach us. It's called the integrated Sachs-Wolf effect, and for a while it seemed to fit, except when astronomers actually searched that patch of sky for a void big enough to cause it, the numbers didn't work. The supervoid they found was real, but far too small, too shallow to explain a cold spot this deep. Caltech researchers ran simulations. The void could account for maybe 10% of the effect, the other 90% still unexplained. That's when the theories got strange. One paper suggested the cold spot isn't a void at all, it's a bruise. The leftover imprint of a collision, in the earliest fraction of a second after the Big Bang, between our universe and another bubble of spacetime expanding right alongside it. Multiverse theory, applied to a single patch of sky you can actually point a telescope at. Another team proposed something even stranger, that the cold spot marks the exact spot where our universe is being pulled, ever so slightly towards something outside it entirely. Something in what they call the multiverse volume, tugging on our expansion from beyond the edge of what we can observe. Nobody can test it. Nobody can rule it out either. And here's the part that should unsettle you. Every year, telescopes get better. Every year, they check the cold spot again, expecting it to shrink, to average out, to resolve into ordinary statistical noise the way anomalies usually do. It hasn't. New data from Planck's final full-sky release confirmed the temperature drop is still there, still anomalous, still centered on the same coordinates it was found at in 2004. Whatever carved this cold patch into the birthlight of the universe did it before atoms existed, before stars existed, before anything you could call space had finished expanding into its current shape. And it left a mark 13.8 billion light-years across that is still visible, still measurable, still cold, tonight, above the southern hemisphere, whether anyone is looking or not. If the supervoid explanation is wrong, then the standard model of cosmology, the one predicting how matter should be spread across the universe, has a hole in it. Not a small one, a fundamental one. It would mean the universe isn't as uniform or as understood as every textbook currently claims. Some researchers now treat the cold spot as a live test case for whether we're missing an entire category of physics, extra dimensions, colliding universes, forces we don't have equations for yet. Nobody at NASA will confirm that on the record, but nobody has ruled it out either. So the cold spot sits there, unexplained, unmoved, still colder than it has any right to be. What exactly left that mark on the birth of everything, and why hasn't anyone found the thing that caused it? Tell me what you think it is, down in the comments.